In this video, I'll show how I made this 3D printed servo motor. Unlike most hobby servos, this servo has 360 degrees of rotation. It also has some pretty fast reaction time. This project was a pretty simple weekend build, and if you'd like to build one of these, check out my Instructable link in the description. Let's begin. Servo motors have DC motors in them. I'm using this 600 RPM DC motor. To drive the motor, I'll be using this BTS 7960 motor driver. Regular servos use potentiometers for position feedback, but because this servo has full rotation, we'll be using an AS5600 encoder instead. These all connect to an Arduino Uno. I designed the gearbox in Autodesk Inventor. Next, I printed the parts and assembled the servo. In principle, the servo works the same as any other servo motor. It's programmed with a closed-loop mechanism that moves the servo to a given position. The servo has pretty much the same capabilities as a regular servo. The only difference is that it has full range of motion. The 3D printed gears were printed without any tolerances, so they have a minimal amount of backlash. It's also worth mentioning that the gearbox has a 3-to-1 gear reduction with a 54-tooth gear and an 18-tooth gear. So because the DC motor has a rated speed of about 600 RPM, the servo has a top speed of about 200 RPM. This makes for some pretty fast actuation. The 54-tooth gear, or the output gear, is also what has the encoder magnet that allows the encoder to read the position of the servo. One design consideration I had was mounting. The gearbox has 4-threaded inserts on top that allow it to be mounted onto other parts. If you get another gearbox and attach an encoder to it, you can map the position of the gearbox to that of the servo. This is a great example of what a closed-loop mechanism looks like. The servo is continuously trying to meet its target. In this case, the target is the position of the gearbox on the right. The servo is pretty strong. Here you can see me doing some torque tests with my fingers. Probably not the best idea. And that's it for this video. Let me know what I should build next in the comments. Also, if you enjoyed this video, consider subscribing. Be sure to check out my Instagram account for more content. Thanks for watching. Thank you.